In this video, we'll learn how to use the sine rule to find missing angles of a triangle. Unlike normal trig, which only works for right-angled triangles, the sine rule works for all of them. Now, the sine rule can also be used to find missing sides, and we'll see that in the next video. Links are in the description or top right corner now. Right, so for any triangle with angles capital A, B and C, and sides small a, small b and small c, we have a special ratio called the sine rule. And that goes sine A over A is equal to sine B over B equals sine C over C. Now we only use part of the rule each time, and we'll see how to use it to find missing angles. Okay, so here is an example. This triangle has sides of length 13 centimeters and 10 centimeters and an angle of 65 degrees. Find the missing angle x. Give your answer to one decimal place. Let's see the method. Okay, so it helps to label the sides and angles. Side A is opposite angle A and side B is opposite angle B. Now we don't need to use C because we only have two sides and angles in the question. So we substitute the values of A and B into the sine rule. So we have sine A over A equals sine B over B, and that comes to sine x over 10 equals sine 65 over 13. And that's because the 65 degree angle is opposite the 13 centimeter side, and the angle x is opposite the 10 centimeter side. And since sine x over 10 means the same as sine x divided by 10, we multiply both sides by 10 to get sine x on its own equals sine 65 over 13 times 10. And to get x, we use the sine to the minus 1 function, usually found by pressing the shift button on your calculator and then sine. So x is equal to sine to the minus 1, open brackets, sine 65 over 13 times 10, close brackets. And this can be entered directly into your calculator to get an answer of 44.2 degrees to one decimal place. It's quite tricky to do this directly, so we'll show you an easier way using the answer key. And we do this by first pressing the fraction button and entering sine 65 in the numerator, before pressing down and entering 13 on the denominator. Then press the right directional button and enter times 10 outside the fraction. Afterwards, press equals to get an answer of about 0.697. This is now stored under the answer key. So to finish, press shift and then sine and then answer to calculate sine to the minus 1 of this decimal here, and that finds the angle. Okay, now it's your turn. Here is another example. Find the size of the missing angle x. Give your answer to one decimal place. Follow the method from the last question shown here on the right hand side. Pause the video and have a go. Okay, here is the answer. We will be using A and B again, so label your sides and angles. So you've got A is equal to the angle x, small a is 6.2, angle B is 61 and 8 is side B. Let's substitute this into the sine rule to get sine A over A equals sine B over B, and then that comes to sine x over 6.2 times sine 61 over 8. Multiplying both sides by 6.2, we get sine x equals sine 61 over 8 times 6.2. And then again, to get x on its own, we use the sine to the minus 1 function. So x is equal to sine to the minus 1 of sine 61 over 8 times 6.2, which when entered into your calculator, by first calculating sine 61 over 8 times 6.2 and then doing sine to the minus 1 of the answer, that gives us an angle of 42.7 degrees, correct to one decimal place. As a bonus, here is one more slightly challenging question that requires an extra step that does catch some people out. Find the size of the missing angle x. Give your answer to three significant figures. Pause the video now if you'd like to have a go. Okay, now where people go wrong is that they forget that sides and angles must be opposite one another to use the sine rule. In this triangle, the angle x is not opposite the 4.5 centimetre side. So here is the answer. What we can do is first use the sine rule to find the angle that is opposite the 4.5 centimetre side. So we'll label that A. Substituting into the sine rule, we have sine A over A equals sine B over B, and that comes to sine A over 4.5 times sine 64 over 7.2. Multiplying both sides by 4.5, we get sine A equals sine 64 over 7.2 times 4.5. And then again, using the sine to the minus 1 button, we have angle A equals sine to the minus 1 of, open brackets, sine 64 over 7.2 times 4.5, close brackets, which when entered into a calculator gets you an answer of 34.2 degrees. Right, now to find x, we just subtract from 180. So 34.2 plus 64, which was the angle here at B, is equal to 98.2. And 180 minus 98.2 is equal to 81.8, which is our angle correct to 3 significant figures. Thank you for watching. I hope you got those correct. If you like the video, please give it a thumbs up. Comment below if you have any suggestions for future videos. Subscribe so you get notified when the next video is out. And feel free to share with your friends if you think it would be helpful.